Hi. Sometimes we have scenarios where you have an infinite lifetime for alternatives or projects. How we could calculate the annual worth of these alternatives. So these infinity project or infinite life project, usually a government projects. Still, we have to compare it with other alternatives. So this example will explain to you how we could calculate the annual worth of three alternatives. One of these alternatives has an infinite lifetime. Machine 1 has an initial cost of 12,000, machine 2 11,000, machine 3 15,000. Annual benefit per year 2,000 for machine 1, 2,500 for machine 2, and 3,500 for machine 3. Salvage value is 3,000, machine 2 4,500, and machine 3 0. Lifetime for machine 1 is 4 years, machine 2 6 years, and machine 3 infinity lifetime. So the first thing you do is build your cash flow year by year and find out what would be the transaction on that year. So for example, for machine 1, on year 0 we have only the initial cost of $12,000. From year 1 to 4 we have a benefit of $2,000. On year 4, in additional to the benefit of $2,000, we have a salvage value of $3,000. And then we build the cash flow for machine 2. $11,000 on year 0, that's the initial cost. Year 1 to 6, we have a benefit of $2,500. Salvage value of $4,500 on the last year, year 6. And then once you build your cash flow for the first two machines, which has a finite lifetime, find the present value using the NPV function. NPV 12%. Select all the values from year 1 to 4, add to these values the $12,000 that is initial cost for machine 1. And next, what you need to do the annual worth for that specific transaction. So now, instead of dealing with 5 numbers, we're dealing only with one number. So we found the equivalent for these transactions in a present format, and now we have to change this format from present into annual worth using the PMT function. PMT function 12%, and this project will run for 4 years, and we need to find what would be the equivalent of this present value of $4,018.75, and that would give you the annual worth is 1323. Do the same thing for machine 2. Find the present value for all these transactions using the NPV function. Add the year 0 to it, and then once you're done, go to the next cell, use the PMT function. PMT for 12%, 6 years. This project will last, or this machine will last for 6 years, and then the present value of 1558. And that would give you an annual worth of positive $379. Now for machine 3 that has infinite life. So we've learned about the capitalized cost, which is A divided by I. And now the capitalized cost, it's another term for what? The present worth, right? So if we need to find A from the present worth, what we have to do, we have to multiply the present worth times I. All right, now, so we have initial cost 15,000. This should be multiplied by I because this is a present format, and in order to change it into annual worth format for infinite lifetime projects, we have to multiply it by I. So we multiply 15,000 and negative 15,000 times 12% and add to that $3,500 to find what would be the annual worth for the whole machine, and that would be $1,700. $1,700 is the annual worth for this machine, and this would give you an conclusion that machine 3 should be selected because it has the highest annual worth. 15,000 times the 12% interest rate, add to that the 3,500 that you're going to get every year as a benefit, and that would give you a 1,700. The final conclusion is, again, machine 3 should be selected because this will provide a higher interest, higher profit comparing to the other machines. Thank you. I hope this is helpful.